anything. Everything is all right? All right. I'm going to be the optimistic fool that I am and believe you for the time being. Okay. Can you turn that light back on? Shoot. Okay. All right, so nobody has anything else they want to discuss. Okay. All right, cool. So let's look at it. All right. So, of course, what's the first thing you always try when I ask you to factor something?
Take something out.
Good, beautiful. GCF, right? Several reasons for that. Number one, it could be the only thing it can do. Number two, it could make the resulting thing easier to do or possible to do. So, for example, if I had this here, let's see, you can do it, Jeff. Oh yeah, let me really throw you guys off. I like coolness. That's evil. Oh, well, too bad. It's a little evil. It's not really evil. So are there any numbers that can come out?
Wait.
Any numbers that can come out?
No.
No, good. 8 and 9 don't have anything in common. I know 8 times 9 is 72, but none of the numbers have anything in common. I like it. So I can't take any numbers out. How many A's can I take out? 1. This guy's got 2, but if I try to take 2 out, he's going to freak. So that's why you always take the lowest exponent out. Right? So I can take 1 A out and 2 E's. So real quick little side note. Notice how I put that over a little bit? So the answer to this goes there. Because one mistake I see is people put that there and then they start doing this and they forget about this poor little dude here. If I have 3 terms now, I better have 3 terms here. So what do you get here?
8 squared.
Good. You had 4 B's, you took 2, you got 2 left. Yeah. You had 2 A's, you took 1, you got 1 left, you got 3 B's, you took 2. You had 1 left. And you took you took A, and you took both B's. Oh, poor little dude. So you get the 9. Alright, so that should be no big deal. That's good old GCF, right? Another bread and butter kind of thing. Here's another example of a GCF problem. This should not be a big deal for us now. It was when you first learned this. That is a GCF problem, but that looks like the last part of a grouping problem, right? And real quick, the reason that's a GCF problem is, how would you factor this? Good. Take a Y out and the 2. I like it, right? So x minus 1 is like the y. What's y? I don't know. What's x minus 1? I don't know. Could be. Sure, they could be. They're both things I don't know, but they both have an x minus 1, so I can take an x minus 1 out. And what else comes out? No. What else comes out? The 2. Same way that the 2 came out over there. You stopped it for a second. So look at your numbers. What comes out of your numbers? 2. Any z's? No. Any x minus 1s? Yes. Do either one of these terms have an x in them? No, they don't. They both have an x minus 1. You see what I'm saying? Maybe. Alright, so then I'm left with here, I took the x minus 1 out. I took a 2 out, so I'm left with a 2z. I took the 2 out, took the x minus 1 out, so you would think I'm left with 0, but I'm really left with 1. Because I divided those out, right? If you have 2 terms here, you better have 2 terms here. How we do? Because when you take something out, you're dividing it out. Something divided by itself is 1. Alright, I can't read you guys at all. That would be so awesome. What the hell are you talking about? Okay. Yeah.
Well, how come you divided it? I thought it was multiplication.
This would be multiplication.
Yeah.
But when you take it out.
But when you factor, you're sort of dividing, right? Because that factoring is the opposite of simplification. So you're just undoing multiplication. And what's the opposite of multiplication? Division. So if I distribute and I multiply, undistribute is divide. Yes? Yes, ma'am?
You could just write that as 4z plus 2 and then factor it though, right?
Totally. Sure. You could have done this, take the x minus 1 out, 4z plus 2. If you stop there, you're wrong.
Right.
Because this can still have a 2 come out. So the 2 comes out, and you're left with 2z plus 1. So you do end up at the same place. Sure. I don't care if you take the 2 out first or if you take the 2 out at the end. The 2's got to come out sometime. As long as it comes out. Ooh, I'm sorry. You good? Okay. All right. How you guys doing? This should be kind of review, but if it's been a while, factoring, you've got to get the factoring down immediately. Summer is going to go pretty damn quick. I don't know if you realize that. We normally do 16 weeks. We got 6 weeks. So it's going to go quick. Don't let yourself get behind and do pre-reviewing. Look ahead and say, oh shit, I forgot that. Let me review that.
For the last one, I would have distributed it so there would be 4x minus 1 in the parentheses, but then it would also be plus 2x minus 2.
Oh, I see. I understand. Almost never will you multiply when you are factoring. Does that make sense? So if the instructions said factor, and I multiply, I'm probably wrong. Because factoring is the opposite of multiplication, right? So if you distribute this stuff, you're getting further away from factored. It's already almost factored, you just have to take out the stuff that's common. If you put that stuff inside, you lost track of what's the same. Does that make sense? So simplify would be distribute and then get like terms together. Factoring is the opposite. I like it. Okay. Let's see that. So what about this here? Oh, Jeff, can you keep track of what's going on? Maybe. Let's see if I can set that up right. First question, are there any like terms here? There's no like terms here, right? I can see already. That's something. Let's see what. So 9.
B.
Oh, that's all. Let's see if this will work. Sorry. Let's see if Jeff did this right. All right. It's always Gary trying to set up a grouping problem out of nowhere. So I just gave it away what you're supposed to do here. This is grouping. What tells me this is grouping besides me?
That's 14.
It's got 4 terms. So if you have 4 or more terms, you group. So that factoring handout that I have up here, it's a little bit loaded with information. Holy crap, but if you look at the very top, it's got a quick reference. 4 or more terms grouping. So what comes out of these two?
2B.
2B.
2AB.
Oh, so close over there. Still not quite right, but oh well, too bad for me. What's left here?
2AB.
2AB
1.
minus 1. And what comes out of here?
Ooh.
Blush?
A
B.
squared.
You're going to love me so much.
9.
And I don't. There we go. That'll work. I don't know why I was overthinking it.
9A.
Yeah, so you gotta. Now be careful. Here's the thing I want to make the point about. This is why I set up with a minus in the middle. When you GCF the first part, the only way this is going to be able to work in the end is if that is the same as this. So then what do I take out of 18a squared b to make it become positive 2ab? A negative 9
A.
a. I like it. So then here you would get
2.
2
A, B.
ab.
Negative
9a divided by negative 9a is
negative 1.
minus 1. Let me stop there for a second. So grouping problems have internal hints. When you get the first part done, this is telling you what this has to become. So it's telling you what you have to take out. The only way this will work is if these are the same. Now, if you had if you had that there, you can't do the next step, even though some people still do anyway. They just say, let me put that and that and that, and just throw it all there and pray. No. Why does the next step work? Is if these are the same, I can take these out. That's the only way it's going to work. If they're not the same, something went wrong. Or Jeff made a bogus problem. So what comes out? This. What's left? 2b minus 9. Alright, I like it. So that's grouping. Grouping should be relatively simple. You just got to be careful with negatives, as always. Alright. Maybe. Now, in general, pretty much if there's no questions being asked, I tend to just kind of go. So if you don't understand anything, you've got to ask questions, or else I'm just going to like steamroll you. I don't want to do that. Okay. Then we talk about this kind of stuff. This. Let me give you one that's a little bit more disgusting. Let's see. Do you trust yourself, Jeff? Maybe. Yes. Nah. So, I want to make this point about this, though. We all know what to look for. What are you looking for? Independent of how difficult you think it's going to be, what do you have to look for?
420.
What about 420? You can have your own feelings about 420. Yes?
Wouldn't it divide it so that the middle number can be split by the factor?
Yeah, and we don't have to do that because the first number is a 1 here. So I know this is x times x. I just need the two numbers that multiply to be this and add to be negative 1.
210.
491?
No, see, those add to be 419.
Oh, right.
You're thinking that backwards. I need two numbers that are kind of close to. I need two numbers that are 1 apart. You guys see that? So let me start. Let me start here. What two numbers add to be negative 1? 18 and negative 19. Don't they add to be negative 1?
Yeah.
Do they multiply to be 420? No. But they come out close. What is 18 times 19? Somebody help me out. 360, 342.
342.
Sorry. Beat your calculators. So 342, is that too much or too little?
Too little.
Too little. So let me try the 19 and negative 20, but that makes... I'm tired now, I don't want to do it. 480. So that's still not enough. I mean, it's too much. 380.
20 times 21.
Yeah, 20 and 21. So the point I'm trying to make is when we teach this, not me anymore, but I used to do this, we focus so much on finding the factors and then checking to see if they add right. You don't have to find the factors first. You can find things that add to be negative 1. That's easy. They just have to be 1 apart and different signs. Does that make sense? What do the two numbers have to do? Add to be negative 1 and, well, okay, find a list of things that add to be negative 1. That's easy. And then check them to see if they multiply to be 420. And then it becomes like a Price is Right game. Higher, lower, higher. It's relatively easy then. I don't know if you guys appreciate it. 420, how many factors of 420 are there? A lot. All right? 2 and 210. 3 and 140. 4 and 105. I mean, oh my God, I'm already tired. I don't know if you guys understand what's happening here. All right, I'm trying to help you. Right? So then what do I put in here? X plus 20? X plus 21. Bam! So when there's a 1 out front, it is easy. You don't have to break up the middle term because x and x, it makes x squared. That's the only way to do it. So then the only thing you don't know are the numbers that go here, and now I do. Okay, maybe. God, I wish I could read you guys. All right. So that's the one thing I wanted to say about that. Otherwise, that should be relatively simple. When it's just a 1 out front, those should be nice, easy, classic factoring problems. Where we get the issues are when the first number is not a 1. So take a minute and try to do this, whatever method you use. Yes, ma'am. Don't say that yet. Don't answer it yet.
Okay.
Give everybody a chance. See what people do. Oh, real quick, you guys in the front row, if you notice the camera turn off, because it's after a certain amount of time, it takes a union break. Let me know so I can restart it. So I think we lost some of that first piece. So there is a method where you just start trying stuff. Maybe this is 4x and x, and maybe this is 6 and 1, and you see, no, that didn't work, let me try something else. The better you are with playing with numbers, the easier that method is. The sort of by the book method is, of course, to do this. 4 times negative 6.
8.
Yeah, positive 8, negative 3, I like it. So then you get 4x squared. How would I write it?
Plus 8x.
Plus 8x.
So the way I would write it is minus 3x. Now, is it wrong? But no, it's not wrong. I just don't let the middle be negative if I can, because that's where people make the simplest mistakes. So if you have an option, don't let the middle one be negative. If they're both negative, screw it. Oh well, just don't make a mistake. I don't know if you guys understand. It doesn't matter if you put an 8 first or negative 3 first. It doesn't matter. These two numbers make the grouping work no matter where you put them.
But then we gotta change it because 8 works with 4.
No. You don't have to change it. What can you take out?
Oh, x.
X. Even if nothing came out, it still has to work. That's why my teacher, I think, is why they called it surefire method. Because if you can find these two, surefire, it's going to work. Oh yeah. I'm from Georgia, so I was cool with that. Surefire, it's going to work. I'm from Georgia. I'm allowed to make that. So out of the first two comes X. What are you left with? 4x minus 3. What comes out of the next two? 2. Thank God I get the same thing, because that's telling me I'm on the right track. So at the end I get
X plus 2.
Why do you think somebody would do this? Don't put that, by the way. That 2 is wrong. Because I see 2 of them, but there's only one that was distributed to both. There's only one 4x minus 3. Alright, I like it. Cool. I like it. How are we doing? So again, if this seems easy to you, enjoy it for right now. If you know you're factoring, that's awesome. That's where you should be. If you don't know you're factoring, oh shit, you need to bring it up to speed quick, because it's huge. Factoring is everywhere. Anybody got to go to, anybody have to take like Math 178, business calculus ever? What kills people in business calculus is an inability to factor. If you can factor, you'll probably be just fine. That's the biggest thing that kills people. They forget how to factor and they're dead in the water, because factoring is everywhere. Okay. So then we're finally to the point where we have, what time is it? I'm going to let you guys out early, like I said. I don't want to start a revolt. Alright, you know squares. Let me give you one that's a little more interesting. I like it. So I just gave it away what that is. Take a second here and try to factor it. I'm not quite done building the college yet, but we figured we'll still do classes. Alright, so difference of squares, if you can identify it as such, is always easy. Always. I just put a lot of shit up there, who cares? So, what do you ask yourself to see if it's a difference of squares? Can everything be cut in half, multiplicatively? Yes. All the powers are even, and the numbers are squares. So then you do that. You cut everything in half, minus plus, you're done. So it's all about identifying the form it's in. So it is a square, so I can put myself some room. 9a to the 5th, b to the
12.
So you get the same thing there. So overall, you recollect, put those together, you make a whole one of those. Half and half makes a whole one. Neat. Minus plus, or plus minus, who cares? It's multiplication, doesn't care what order it's in. Same thing here.
5 over 10 Z2.
There you go. Done. Because whatever this is the opposite sign of what this is. So the middle terms will cancel. Did you guys get that? So that is the same problem as this. They're the same exact problem. There's just a little less writing on the second one. Alright, well, how's the second one?
X plus 7, X minus 7.
Yeah, you put one of each, plus minus. Okay, I like it. And then finally, you got cubes. We talked a little bit about cubes earlier. Let's do a couple examples real quick. Oh, by the way, I put that we're still basically reviewing chapter 6 right now. Tonight, everybody's got the, you can go to the website and grab the first assignment from the website, right? So everybody should be able to do that tonight. Because tomorrow you need to come with your questions. So I didn't want to just go through every chapter before this and just remember this. No, I want you to come in after having tried it and say, I don't remember this. I got a question on this. Just everybody come with your questions tomorrow. Do you understand? So tomorrow's just going to be just remembering all the stuff that we've forgotten. Yeah.
Both assignments?
The appendix one is something new. So hopefully tomorrow after the review, I'll talk about what the appendix is talking about. So do you guys remember long division of polynomials?
Yeah.
My guys do, I know. And isn't it awesome?
Yeah.
I like it. Beautiful. That's the correct answer. But even me as a math, I don't like writing all that shit down. So there's a shortcut to it. It's called synthetic division. It sounds horrendous, but it's actually kick-ass awesome. So tomorrow, after the review, after you ask your questions, we'll talk about that. That'll make the long division easy. All right.
Just the review or the appendix?
Yeah, the appendix is referencing, if I remember correctly, it's referencing synthetic division. Where is my appendix? There it is. AP 27. Yes, synthetic division. I love it. So we'll talk about that tomorrow.
For that problem, you have to answer just like that.
This year? Yeah. Because there's nothing else that comes out. Right? And they're not squares anymore because 5 is not something squared. I like it.
These homework problems from chapter 7, are they the same from Math 90?
I can't remember. I didn't really look to make that happen. They're probably different. Because if you're worried about, I always get complaints about the amount of homework I give. And I don't give a shit. Right? And here's something about it. I think there's the amount of homework you need to do to really get it down. I've cut it down for the summer already a bit from what I normally do, and obviously I have to. So I try to get it down to its essence. But to be honest, here's how you approach any class with homework. You do enough homework to understand it so you're ready for the test. If you're able to do every homework problem the teacher assigned great. If you're not, oh freaking well, right? That's fine. I don't want you to be, I didn't even try these sections before the test because I didn't finish it. No, that's crazy. If you're getting behind, just start trying some out of the last few sections. Don't take a test without practicing for it. It doesn't make any sense. You guys understand what I'm saying?
Yeah.
I'm telling you, try to get all the homework done. If you can't, try problems out of every section so you're not shooting yourself in the foot. You got to practice for the test. All right. And then you can grumble about how much homework I signed. I don't care. Yeah. Yes.
I remember you wanted to mention something about the E30.
Oh, yeah. So if on the homework sheet, you were asking about that E30, E50. If you look at the homework sheet, what does that mean?
And on.
Every third one.
Beautiful. It says so at the very top. The homework sheet explains what it is. E30 is every third one. 3, 6, 9, 12. You guys with me? So you're like, the problems themselves are problems. Thanks, Jeff. I got E50 every fifth one, 5, 10, 15, 20. I think I got some E70s in there somewhere. Guess what that is? Every seventh one, 7, 14, 21. You guys understand? Try to stay on track, but if you get off track, you don't have to redo the whole thing. Just easier for me to grade. The reason I do that is so I can give you a wide selection of problems without do number 7 and 11 and 15. I always hate to see that from teachers. They have this long list of specific problems. Screw that shit. Just I want to slice through all the homework and get you all these different types. You guys, everybody understand? E30 does not mean every third odd. Don't get overly optimistic. The homework would go fast. You're like, what are you talking about, Jed? This is fine. It's bad. You've done not quite all the homework. Okay. Oh, before I leave squares, what about that extra credit? Well, let's do this one first before we do the extra credit one. Obviously, I just gave it away. It's a square. So there's 2 terms. So it can only be squares or cubes. There's no GCF, right? Obviously, it's got x's and numbers.
Right?
No, it's not prime. No. Can he cut everything in half?
Yeah. No.
Totally, of course. So it's a squares.
Oh, but with
X2 minus 9.
I like it. Now, which one of these can you factor? The minus. You can't factor both.
Because you can't do a sum of squares.
So why do squares work? Because to make a negative number, I have to have different signs. If they're different signs, they will cancel each other. So the middle terms cancel. So if it's positive, they have to be the same sign. Will the middle terms cancel? No. Shit. So if you think this factors to be this, why are you wrong? Because the middle you get 6x. Is there a 6x? That can't be right. So what if it's minus minus? Same problem, minus 6x, no good. So the reason squares works is because it's a minus, difference of squares, they can be different signs, they can cancel. Sum of squares is prime, at least using real numbers. When we learn complex numbers, we'll factor them. But for right now, that's prime, leave it alone. This one though, x plus 3, x minus 3. Bam. Bam. So when your power is higher than 2, there's a chance you're going to do multiple steps. Okay. Why didn't 81 is going to work? Because it's 9, 9. Both 9s are squares. What other number would work here? 16. Because 16 is 4, 4, and 4 and 4 are squares. Maybe you guys start to see what to look for. And real quick, I didn't do that extra credit one. Well, I'm getting really up there with my Roman numerals here. Was that there, right?
Yeah.
So the correct way to do this is to look at it as squares first. So let me put that up here. You guys back there are like, come on, dude.
X3 minus plus 8.
Yeah, x6 would be what?
X to the third.
64 courses,
4.
8 and 8. It's the squares we're looking at it. Now, what are each of these? Cubes. So this is a nice segue into cubes. So how do cubes work? Well, you break everything in thirds now because it's cubes.
X minus 2.
then x squared plus.
All right, let me catch up to you. So little dude, big dude,
Yeah.
little dude, big dude.
So the negative one would be x minus 2, and then the x
X
squared,
equal
and then 4 on the
2x.
outside, and then
The
2x.
middle term is always
Positive.
2 times x, opposite sign. Why does the opposite sign make sense? Because it's the cleanup dude. It's got to cancel the stuff. So it's got to be the opposite sign. So there is a little thing that I started using that I hate using too many of these because it removes you from why things work. But this one I'm almost okay with. Oh, that sounds good. That's the same sign. That's the opposite sign. And that's always positive. Right? So you're using so that's okay with me. But I don't know if you guys understand. The more you do that kind of thing, the less you remember why it works. Why is this the opposite sign? Because it's got to be the cancel dude. It's got to cancel shit you don't want. This is a nice little tiny way to remember what the signs are and everything. Same, opposite, always positive. So this would be the same sign. X and 2.
X equal
This will be the opposite sign.
negative 2x
2x, I like it.
plus 4.
Plus 4.
Now we have to like
And that's it.
that's it.
You can't, it's times. There's no like terms to talk about. Yes?
Where do you keep getting the 2x that's in the middle of
The middle term is all